And I'm also happy that everyone is sitting in the front a little bit. If I would do the same thing in Belgium, where I'm from, everyone would sit in the back and be silent. So thank you all again for being here. So today we will talk about what is new in .NET and the future of .NET. First presentation of the day. First, my name is Johnny. I'm not here to talk about myself, but I will just give a short introduction. I am a developer every day. I'm a consultant in Belgium for a consultancy firm, and I just like to play around with everything that is .NET and JavaScript. I am a Microsoft MVP, and because of that, I have a little bit more knowledge on .NET, so I could play around with the new version of .NET a little bit earlier than you guys. So I really had fun the past year. Everything that I will talk about today, everything that I will show you today is already on my GitHub page. The link to my GitHub is in the bottom of each slide. So if you have any questions or if you want to play around with the stuff that I'm showing you today, you can just go over there, download the entire repository and start playing for yourself. Now also the PowerPoint slides that I will show you today are already up there. So you have everything available. If you have any questions, we will have a Q&A at the end of the session. But you can always contact me on Twitter or even my professional email address if you'd like. So I would be more than happy to answer your questions. So let's stop talking about that and let's just get started. So first I'm going to give you a little bit of a history on .NET. So basically in 2002, Microsoft released the .NET framework. And then today we are at .NET 6. Lots of things happened. There's actually multiple different platforms in .NET. We have the .NET framework, we had .NET Core, and today we have .NET. I really like it if developers could use the correct names for all of these platforms because they are a little bit different. So if you're talking about the old .NET, you talk about the .NET framework. If you talk about .NET Core, that's easy. It's just called .NET Core. And then if you talk about the new .NET, you just say .NET, nothing else, so just .NET. And that's the 3 separate versions of .NET. Why is this happening? Well, basically Microsoft started with the .NET framework in 2002, and it runs up until today and in the future. That's a pretty long time for a platform to be evolving. And the .NET framework evolved to be a very big, vast framework, so many things inside, and it also grew in size, it grew in installation size, so it was becoming a little bit cumbersome. And that's why Microsoft decided in 2016 to start from scratch. They really wanted to build a new platform that was more performant, open sourced, but also runs on as many platforms as possible. And that's when they started with .NET Core. I've been teaching .NET and C# for 10 years, and for me this was a little bit difficult, because if you are a new developer or if you are a student learning .NET, it's very difficult. There's a difference between .NET Framework and .NET Core, so it caused a lot of confusion. And that's why Microsoft decided last year, they probably decided longer beforehand, to create one unified platform. So no 2 separated platforms, no .NET Framework, no .NET Core, no just .NET. And .NET would be just everything, which I think is a very good decision. And they made that decision in 2020, last year, by releasing .NET 5. This year, 2021, actually a few weeks ago, beginning of November, they released .NET 6, and that's what I'm going to talk about today. And each coming year, Microsoft has decided to create a new major version of .NET. So there will be many changes. Things will grow very, very quickly. Now, you need to know that the .NET framework still exists today, and it will keep on existing for a number of years still, because lots of our industry is still using the .NET framework, and it's very important. I have listed here all the support dates for the current versions of .NET, and you can see that many of them are green. Even the first 3 don't have an end date. So basically they are supported indefinitely for now. So not really indefinitely. But you can also see that, for example, the .NET Framework 2 and 3, they have already expired a long time ago. They are out of support. .NET Framework 4, 4.5, and 4.5.1, they expired in 2016. And then 3.5 Service Pack 1 will expire in 2029, which is a little bit weird. But basically, the .NET Framework is tied to specific versions of Windows. And because of this, the support dates are actually tied to these releases of Windows. So the .NET Framework 3.5 Service Pack 1 is tied to a Windows Server version, and it will go out of support when that Windows Server version goes out of support. The latest version of .NET Framework 4.8, will go out of support when Windows goes out of support. And in the past, that was Windows 10, but now we have Windows 11, and the .NET Framework 4.8 is still shipped with Windows 11, so it will go out of support whenever Windows 11 goes out of support. And if Microsoft decides to ship it with the next version of Windows, it will just keep on existing. So that's very good news for us as developers, because when we are still doing the .NET Framework, we are still supported, so that's very good. .NET Core, it's another story entirely. The most versions of .NET Core are already out of support. The last long-term support version of .NET Core 3.1 will go out of support next month. So if you are still using .NET Core, you should migrate to .NET, basically, because you have less than 1 month remaining to do that. Of course, the application will not stop working immediately, but you won't have support. You won't have security fixes, you won't have patches, nothing will happen. You are just using that version that is officially not supported. Well, why is Microsoft doing that? Because .NET 5 and .NET 6, they are basically just .NET Core. They are new versions of .NET Core, but they just changed the name from .NET Core to .NET. So it should be very easy for you to upgrade your .NET Core applications to .NET 5 or .NET 6 and so on. Shouldn't be too many compiler errors there, so it should be relatively easy. Now, what is the support cycle of the .NET platform looks like? Well, there's going to be 2 separate releases. There's the long-term support release, and there's the other releases. And basically, the .NET platform will release every year, and then every even year, there will be a normal version, and every odd year, there will be a long-term support version. So last year, we had version 5 in 2020, which was an even year, which is a version that it will only be supported for 18 months, and after 18 months, the support will stop. .NET 6, which came out this year, 2021, an odd year, will be a long-term support version, and that will be supported for 3 years. So there's a difference between this. So next year, we will have .NET 7, which will also only be supported for 18 months. But then, of course, when you are using .NET 6 today, it will go out of support in 3 years. But by then, we have .NET 8, which is a new long-term support version, so you should upgrade from 6 to 8. And then from 8 to 10, and so on. But we will see what happens after that. Still many years to come. But of course, you're not here today to talk about support for .NET. We are here today to look at some new features in .NET 6. Well, I really like to talk. And when I want to show you all of the features for .NET 6, we will be here for 4 to 5 hours. I would like that, but the conference organizer does not like that. So I just picked the things that I like most, and I will show you those things. So first, something to talk about. I can't show you this, but Microsoft really put a lot of effort in increasing the performance and the architectural of the .NET platform. So basically, they completely rewrote the runtime. They already did that for .NET Core. They wrote their runtime from scratch. Basically. The runtime is the base class library, but it's also the JIT compiler, and they also redid the JIT compiler from scratch, and they even improved it more for the .NET platform in .NET 5 last year and in .NET 6 this year. They introduced all kinds of techniques to increase the performance. Because to be honest, if I now look back into the .NET framework, it's actually much slower. There's less performance there than there is today in .NET. When you compare these two, there's a big difference. There's, for example, ahead-of-time compilation, where you as a developer can specify which platform you are compiling to, and then specific code can already be compiled to machine code instead of intermediate language, which makes your application startup time faster, which makes your runtime faster, and so on. There's tiered compilation, which is a crazy feature in .NET. Previously in .NET, when we are just-in-time compiling your code at runtime, the compiler, the just-in-time compiler, would do some optimizations for you while your application was running. But doing optimizations to your code takes time, because the compiler needs to think about, okay, how can I optimize this code to run faster for the platform you're compiling to? Well, today, with the .NET platform, when you start an application, it will try to compile it as fast as possible without any optimizations. The thing is, when a user starts your application, it just runs. It should just run. Tiered compilation means that if you are calling the same methods, the same code multiple times, it will be recompiled by the just-in-time compiler. Because the just-in-time compiler sees, okay, the user is calling the same code over and over, which means that that part of your application is important. So I'm going to try to recompile it in the background and do some optimization so that it runs even faster when the user calls it multiple times, which is a very cool feature. And that's also why your .NET applications start up very quickly, because there's no optimization there. The optimization comes afterwards. There's stuff like profile-guided optimization, which means that stuff that runs when your application starts will be much closer to the start of your binary file, so that they start faster, that they're easier to access in memory, stuff like that. There's platform intrinsics, which is just crazy. In the past, when you really wanted to call functions for your CPU specifically, you need to use languages like C++. Today, you can call processor functions directly from .NET. If you want to use like single instruction, multiple data instructions for your specific Intel CPU, for example, you can call that directly from .NET by just adding some classes to the base class library. Very powerful stuff. And then finally, there's source generation. So today in .NET, when you would do, for example, reflection is always a little bit slower because you need to look at the metadata for your assemblies. Well, source generation generates source for you while compiling, which means that at runtime the source is already there. You don't need reflection to figure stuff out, and it just runs, and it will be much more performant. So all of these features make sure that .NET 6 today is very performant, very fast, and there's a real difference between that and .NET Framework. Then, the single SDK experience, and this is something that I'm very, very happy about. So let's open some code now. So basically, in .NET 6 and .NET 5 already, Microsoft changed the .NET SDK so that you can do everything with the SDK itself. Previously, you almost always needed Visual Studio to do stuff. But today, there's a single command line tool, which is .NET, and you can do everything from that. You can create new projects. All the project templates are within the SDK for .NET. They're also in Visual Studio, but you don't need Visual Studio to create a new ASP.NET Web API project, for example. You can do that from the command line, which is very powerful. You want to run your unit test, you want to publish your application, all of that stuff is part of the SDK. You don't need Visual Studio to do that. So you, as a developer, have all the freedom to do whatever you'd like, how you want to develop code. You can still use Notepad and the C# compiler directly if you want, but of course all the tools within the command line are very powerful. A thing that's also changed is the project format. If you look at C# projects, depending on what kind of project you're generating, it looks a lot simpler than it did in the .NET Framework. There's just a few lines of properties you can set, and if you want to have some additional things configured, you just add those properties to your project file. The target framework is just one single thing that you need to change. It's just this moniker. So .NET 6 means you're using .NET 6. Do you want to downgrade your project to .NET 5? Well, just change the 6 to a 5, save your file, and my project is .NET 5. That's literally the only thing that you need to do to go from 5 to 6 or from 6 to 5. Very easy. Also, if you look at, if you open your project and you look at the dependencies and then frameworks, you can see that this is using the Microsoft .NET Core app package. So basically, the version of .NET you are using is just a package that's referenced automatically for you. If you look at the properties for this package, you can see that's using version 6. If I change the 6 to a 5 and save my file, and hopefully when I do properties now, you can see it's automatically version 5. So you don't need to do a lot to make that happen. Even cooler, when you are building other kinds of applications, so for example, a WinForms application, which is specifically to Windows. So today you can write console applications or worker services for multiple operating systems, multiple processor architectures. But if you want to do WinForms, it only runs on Windows. So the target moniker for .NET 6 for Windows has the additional dash Windows in its name. And what happens with this is you are creating a .NET application that can only run on Windows, but because of that, the base class library basically expands. So there's a couple of more namespaces and classes and methods that you can use because of that. And you can actually also see that in the dependencies, frameworks. Now you have an additional package. You have the Microsoft Windows Desktop App Windows Forms package automatically. If you just remove the dash Windows, that package disappears. It's gone automatically. And if you re-add Windows, it appears and it's there again. And adding these packages dynamically just for us makes it easy. We have some additional namespaces we can use and we can do cool stuff with that. It's the same for WPF, but you can take this even further. Here, for example, I'm using a very specific version of Windows 10, or of the Windows 10 SDK. I'm telling the SDK, the .NET SDK, please create an application for Windows, but for Windows 10.0.19041 specifically. And then if you open up the same dependencies package, you can see that there's even an additional package being added. Now there's the Windows SDK.NET reference package. And this has even more functions for you to use, even more functionality for you to use. So this is, for example, a WinForms application. If I run it quickly, it's a WinForms application that can use my webcam to take a picture. It's going to be very beautiful, I think. Yeah, that's too much light. Hello, yeah. It looks beautiful. There I am. Yeah, this is the most crappy webcam I've ever seen. But if I open my WinForms, you can see I'm using classes like media capture, image encoding properties, and I can use my capture manager to capture a photo from my webcam, and I can store it to a storage file. All of this functionality is not by default in WinForms, but I just enabled it by adding the additional version number, and now I can use a part of that Windows 10 SDK very easily. You can see that there's the windows.media and the windows.storage namespaces. If I go back to my project file and I just remove that version number, and I go back to my form, and I wait a little bit, you can see that those namespaces are not available. Now they are gone. They are not part of the base class library. They're not part of that package that was being included. So for us as developers, it becomes very easy to specify which parts of the .NET platform I want to use, and then they just become available. So very powerful stuff. And of course, there's stuff like ASP.NET. If you look at ASP.NET and then the framework dependencies, there's the additional ASP.NET Core package, which is also defined by the SDK moniker in the top. So we are still using .NET multi-platform, but now the SDK is not just the .NET SDK, but we have the additional .web, which makes it, which provides an additional package for web applications. And of course, there's MAUI, but MAUI is still in preview today. When it will get released, we can even do more. We can create mobile applications for Android, iOS, and so on. So let's go ahead. Oh, one more thing. Because .NET 6 is a long-term support version, if you go to Windows Azure or Microsoft Azure, and you create a function app, so if you just want to write C# as a function app in Azure, you can select the .NET runtime, and .NET 6 is already available for you there. So if you want to use .NET 6 for Azure function apps, it's already there. You can use it. You can use all of those new .NET 6 features. So very, very cool that they already added this to Azure function apps. Yeah, you can still use .NET Core 3.1 because it's still supported up until next month, as I told you. But I expect that from next year, they will remove that support here. And you can only do .NET 6. All right. There are also a couple of new deployment features that I want to very quickly talk about. First of all, if you build an application in .NET Core or .NET, it's not really a new .NET 6 feature. It's already in .NET Core, but maybe you don't know. If I run or if I compile a console application, you need to be very careful. There's always going to be a DLL and an executable, and this is what they call the default executable. Basically, all the .NET code that you are writing in your console application is not in the executable, it's in the DLL file. So your DLL is your .NET assembly. And then the executable file is actually a wrapper. It's a native wrapper that starts up the .NET runtime and then loads in your DLL. So when you are creating a console application or a WinForms application, there's always going to be that DLL, and that DLL will contain all of your intermediate language managed code. So be very careful with that. If somebody asks you to write a very quick console application, not only give them the executable, but also give them the DLL that comes with that. So this is a very important change from .NET Framework. In .NET Framework, you only had the executable. Now you always have the two. So very important for you to remember. Of course, another cool feature in .NET 6 and onwards is that you can specify the runtime identifier, which is what I talked about before. If you know that your application will only be run on Windows, you can immediately specify that your runtime identifier is Windows 10 for 64-bit processor architectures. And this means that when you publish your application, so let's very quickly do that. It will generate everything that is necessary to run your application. The user does not need to install a .NET runtime. They can just have a fresh install of Windows, nothing else, and your application will run without an issue. So if I open my File Explorer, nope, it's this one. This is what your application looks like. This is a Hello World console application. It's a little bit over the top. There's like 240 files in here, and I think it's about 100 megabytes. So if you're writing a console application for your grandmother saying, "I love you, grandmother," or something, and you give this to her, I think she will be suspicious. She doesn't really know about computers, but she will be suspicious. And because of that, we can add an additional parameter, publish single file. So basically, we can put everything together in one single executable, and then it looks less suspicious when you're doing a console application. So if I go back here and I go to my published folder, this is my program debug file, so this one can be deleted. You don't need that. And now you have a single executable file. Depending on how IT smart your grandmother is, she will be, okay, nice, I've got a little application for my grandson or granddaughter. But if she is smart enough, she will see 61 megabytes for a console application. That's still suspicious. But of course, this contains everything. This contains the .NET runtime, the base class library, the just-in-time compiler. All of that stuff is within that single executable, which is quite powerful. Now, one more thing that you can add is publish trimmed equals true. So here the compiler tries to be smart, and it will remove all the parts of the base class library that you are not using, or at least as much as possible. Of course, it's very difficult to do that, but it will try to make that size a little bit smaller. I'm not going to show you for time purposes, but if I compile this, it will be around 15 to 20 megabytes in size, which is better than 60, but it's still a lot. But of course, we still have the runtime, we still have the just-in-time compiler, but it is a powerful feature if you like to do stuff like that. Of course, when we are just deploying stuff to servers and nobody sees, it doesn't matter that we are deploying 400 files, 100 megabytes, but the option for us is there to use these kinds of things. There's modernized templates. So when we do .NET New and we create a new .NET application based on a template, all of these templates are modernized. And this is one of the biggest changes in .NET 6. So if I go to Visual Studio, it's the same in Visual Studio, and I create a console application, for example. This is what a console application looks like today. I am not sure if I'm a huge fan of that. I'm an old school developer. I like my namespaces, I like my classes, I like my methods. But basically, they stripped all of that out. The only thing you see is code. This is your main method, but your main method is not visible. This is purely C#. .NET does not know about this feature. This is purely the C# compiler. When you compile your application, the namespace and the program class and the main method will be added for us. But of course, when you're teaching students, for example, this is very powerful because they don't need to look at all of that stuff around. You can just focus on writing code, on declaring variables, on creating like if or loop structures. So it's very powerful. But of course, when you're doing a simple console tool for your operations friends at work, maybe they like this because it's easy to comprehend. So if you do file new project today, this is the default. If you really like your namespaces and your program classes, you need to add them by yourselves. Or there is a setting in Visual Studio where you can change it to be back like in the old days. And it's basically the same for all of the templates. If you look at an empty ASP.NET application, there's no startup class. Nope, everything is in your program class, and it's the same top-level program as you could see in the console application. You have your web application builder. Even when you're just doing ASP.NET empty application, you even get like endpoints that are defined using a minimal API. So you don't need controllers. You can just specify, this is my endpoint and I want this data to be returned, which is also cool if you like that. So you have many, many options. For MVC, it's the same thing. You don't have your startup class. Everything is here. You can declare your dependency injection by just doing web application builder.services, and then you can add whatever service that you need. And maybe you're a fan of that, maybe you're not. But by default, you will get this approach. So you have less files to look at, basically. And yeah, this is the last one that I'm going to show you, but for like a worker service, again, it's the same thing. It's your top-level program. You just have your host builder, you configure your dependency injection, and you add your worker to that, and that's it. That's all that it looks like. So all of these templates have now been, again, modernized, and they will look like this. Next, I have a long list of new base class library features for .NET 6 and a couple of C# 10 features that I really like. So first, what will I do first? Yeah, global usings, for example. This I'm actually a fan of. Previously, when you had large applications or large code bases that use many files with many classes, you had like 1 million usings, and then your code was there. Today, you can put usings that you're using in many files into a separate file, and you can call them global usings. Again, this is a compiler feature. It doesn't really exist in the .NET framework itself. When you compile your code, all of your global usings will be copied to all of your files. That's it. So you don't need to do it by yourself. But if you're using like system.console in all of your files, just add global using system.console, and you can use it everywhere without adding the using there. Another thing that is a little bit similar is implicit usings. So in .NET 6 and in the new templates, implicit usings are enabled by default. So this property will be enabled by default, which means that stuff like system and system.io, system.threading.tasks, all of those things that you use very often are added implicitly, which means you don't need to add them. You don't need to add them as a global using. They will be added by the compiler automatically. So your using blocks will be much smaller because all of those default base class library namespaces that you're always using will be there implicitly. If you don't like this, you can customize it yourself. I can do implicit usings disable, so I don't want to use implicit usings, but I can add an item group to my project file to say, okay, I'm going to include system everywhere. And now you can fine-tune it all by yourself, whatever you want. You can do like the static using, which means that you don't need to write console. You can just use the methods directly. You can do it like this. Just add it to your project file, and I can just do write line everywhere, and it will just work. You can also create the aliases. If you want system environment, and you just want to type e.getComputerName, this is the way you do it. You just add the implicit using for system environment with the alias e. So very, very cool stuff. Now some .NET things that are new. This one is something that I like, the argument null exception. So previously, when you wanted to check your arguments for being null, you needed to do like, if my text is null, I'm going to throw a new argument null exception. Today, finally, we have like a static method on the argument null exception that does throw if null. So you have one line of code to just add the throw new argument null exception when this parameter is null. And then automatically the name of the parameter will be added to that exception message. Very simple new feature, but it's there nonetheless. What else do we have? For example, the periodic timer. If you like timers, but you want to do your intervals another way, you can use the periodic timer, which is a timer that will trigger, in this case, every second, but you can specify the time span. And then you can do a while loop with an await, like an asynchronous await for the next tick. So your timer is running, and you can await for the next tick, and you can do that in a loop if you want. So this is another way of doing a timer. Instead of using an event or a function that needs to be called whenever the timer ticks, now you can just await for the next interval. Again, a very, very small new feature in the base class library, but if you like to do it this way, it's very cool that it's there. Priority queue. It's a new kind of queue. We already have many, many, many lists kind of things. We have lists, we have collections, we have dictionaries, we have queues, we have stacks, and today we have priority queue. So you can queue something from whatever type you need. So in this case, I'm queuing a bunch of strings, and then you can add a second parameter to that. In my case, it's going to be a byte, and it will be ordered by this byte. So it's an ordered queue. So if I'm adding an apple and a banana and a lemon, I can pick the order. So the apple goes first, the banana goes second, the kiwi goes third, and then the lemon and the peach share the fourth space. So this will just use the default queue, first in, first out, and they will be ordered within that queue based on my queue type, order type, I mean. You are free to use whatever type for the order, if it just can be compared, if it implements from the comparable interface. So if you have your own custom type and you have a comparer for that type, your priority queue can work with that. Very powerful stuff. Another thing, parallel for each async. Finally. So the parallel for each helps us to run code in parallel. Depending on how many CPUs you have, they can really physically run in parallel, which is a very powerful feature. But up until today, we were not able to do asynchronous code because the parallel for each would just start and it would not await for that asynchronous code. So if you, for example, had a max parallel degree of 3 and you run 100 async methods, they would not go 3 by 3. They would just run all at the same time because the parallel for each was not waiting for the result. But today you can do parallel for each async and you can await. And now it will really await for each task individually if you have like a maximum parallel degree specified there, which is also very powerful because now you really can, as a developer, can say, okay, I only want this many tasks to run in parallel. But of course, your list can be longer, so those will be queued, basically. All right, then. Yeah, for some reason it has taken this long, but finally it's here. We already have date time since 2002, but today we have date only and time only. So if you only want to use time and only want to use date, you don't need to work with date time. You can use date only and time only. Very cool. If you want to create a date or a time, you can do that using a constructor and adding like year, month, and day, or a time with hours, minutes, seconds, and so on. But you can also create that from a datetime with the static function from datetime or from time span. So also very cool. Some other things SDK-wise you need to know. By the way, the default new templates for Visual Studio and .NET have nullable reference types enabled by default. If you never used nullable reference types before, it means that if you declare a reference type, that it's not going to be nullable by default. So if you want a nullable type, you need to use the question mark or the nullable of t specifically. And this is now enabled by default. So again, if you're not using that today, it's going to be a little bit confusing for you because you will get a lot of warnings from Visual Studio and from .NET that will tell you this reference type can be null, you're making a mistake. It's just because this little parameter is here. If you don't like that, you can remove it. But again, I didn't like that, but I'm trying to teach myself to really use that and be more and to work more with non-nullable reference types. Something C#10 specifically is interpolated constants. So this is something that's finally here, but beforehand you could not do something like this. You can not have an interpolated string that is building on top of other constants, because this is not constant, this is variable. The compiler didn't really like this, but of course we know as a developer that it's still constant. If those things here are constants by themselves, then this is constant as a whole. So today it's supported by the compiler. The compiler has become smart enough to know that this is constant, so now we can do stuff like this. Finally. Some other C# feature is file-scoped namespaces. I didn't really know that I needed this, but actually I'm very happy that it's here now. I didn't know that you could have multiple namespaces in the same file, which is of course logical, but I never used that. For me, one C# file was always one namespace. But if you only need one namespace in a single file, you don't need the curly braces. Whoops, that's not what a curly brace looks like. So yeah, like this. So this is what it was beforehand, and nothing really wrong with that, but of course all of your code goes to the right-hand side. And now, very simply, we can just remove those curly braces if you only have one single namespace in a file, which I'm always doing, and your code goes a little bit to the left and you have more screen space to use. So this is such a simple feature, and it took so long for Microsoft to implement this. But again, it's finally here today. Yeah, and then in the previous version of .NET and C# specifically, we had records. So a record is an immutable data type. So we have classes, we have structs, but now we have records. So this person class is a record, which means that all of its properties should be immutable. So I can create a new instance of this record. I can set the properties, but after that I cannot change anything. The object is there and it cannot be changed. Well, you could use read-only properties. You know that. If you have a read-only property, you can also not change those properties. So what's the difference? Well, basically, for an old-style class with read-only properties, you couldn't use an object initializer. You could only use a constructor to set those properties. And that's why Microsoft decided to add the record concept and then the init concept. And init means you cannot set the property, you can only initialize the property. But you can initialize that property from the constructor or from an object initializer. So from both. And that is exactly what I wanted a long, long time ago. You can also do it like this. You can use like the constructor syntax as part of your record signature. So there's record person2, and there's a name property and an age property. And because they are properties, I have used capitalized letters. So they will be added as these kinds of properties automatically, and they will also be init by default. So this was a feature from last year. The change today is that you can do record struct. And to make things a little bit confusing, of course, I didn't tell you, if you don't know, a record does not exist in .NET. This is just syntactic sugar from C#. If you compile this, it will just generate a class for you, because record does not exist. And that class has some additional methods implemented for you with source generation. So that record has it can compare to other records by value. It can do it to string automatically, showing you all of the properties. So all of that functionality is for free. You don't need to write it manually. But some people, they really like to use structs instead of classes, because a struct is a value type and a class is a reference type. So if you want to do that, only from today with the new version of C#, you can use a record struct. If you really want to specify it like this, a record class, you can do it like this, record class. That's also valid. I already did it right here, but now you can do record struct. And then to make things confusing, this name and age, if you do it like this, will automatically generate properties that are not in it, but have a setter. So a record struct by default is mutable and not immutable. Not sure why they did that. But if you want it to be immutable, you need to add read-only. So it's going to be public read-only record struct person5. And now you have the same kind of functionality as the record class, but now you have the record struct with the immutable name and age. So try to remember that if you want to use it. So did I cover everything here? Yes, 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 yes. Number 5, some new JSON features. Yeah, Microsoft really got into JSON. They really want to kill and destroy Newtonsoft with that. I think in .NET 5, Microsoft finally added the system.text.json namespace where we can do JSON-related operations. And today they added some more JSON features. So for example, this is something when you create like a model or a data transfer object that needs to be serialized and deserialized, you can add, let's make it a little bit bigger, you can add these two interfaces or even more. So iJSON on deserialized or iJSON on serializing. These are kind of events. So if you implement the functions that are defined within these interfaces, you can do something when your model or DTO is being serialized or is being deserialized. It can be handy for debugging or other functionality that you want to trigger specifically when you're serializing or deserializing. For debugging, it can also be very powerful because now you know when the same object is being serialized 1 million times, then maybe you made a mistake and you can now add these kinds of events to figure that out. So whatever you want to do with that, just go ahead. Just don't start calculating stuff that takes an hour when you serialize or deserialize an object. That would be a little bit weird. What else do we have? We have some document object model related functions for JSON. So you know that you can use JSON node to parse and to generate JSON structures. So I can parse this JSON string into a JSON node, and then I can use these new indexers and methods to get specific values within that JSON. So I can do node and then go to the age property and get that value as a byte. And now I have like a type safe way of getting that value from that serialized or from that parsed JSON. If you want to generate new JSON objects, you can do it like this. I can create a node, it equals a new JSON object. I can say, okay, it has a name property which equals my name, an age which equals my name, age, an address, which is again a new object with a street property which is not my street, and a bunch of numbers because I own multiple houses. I'm not sure why I did that, just to show you that there's an array possibility. You can create a new array which has 3 numbers. And then you can do again the other way around. I can use that bigger node to get the address, to get the numbers for that address, and then the second entry, and I can get that value as an integer. So now you don't need your C# models to serialize and deserialize. You can just dynamically dig into your JSON and get specific values from your JSON if you want. We have async enumerable. This is a very, very cool and a little bit weird feature. But some time ago, we got the concept of async enumerable. We could do await for each, where we await a stream of data coming in. So instead of awaiting the entire process to download everything first and then for each item, we can now await for each. And it can be a stream of data coming in, and the await will wait until the next item comes in, and then we can execute some code. Now JSON has support for this. So this is a very weird example that I created where I can stream a list of people. So this is an async enumerable of person. It's just a for loop with 20 items, and it will yield return a new person. It will wait for 1 second. So basically it's a stream that streams 20 people with a pause of 1 second in between each person. So this is an async stream. Now, I can do an await for each on that. And what I'm doing here is I'm storing that stream of people, and I'm going to serialize that stream of people, and I'm going to serialize it to the console output. So this is just to show you that when people are being streamed in, I'm going to serialize that stream while it's coming in, and I'm just going to output it to the console so that you can see it. So again, I'm serializing a list of people to JSON. That's what I'm doing. But that list of people is a list where I don't know how many people there are, and they're just coming in dynamically. So when I start this, you can see that the people are coming in one by one, and I'm just streaming that JSON while the people are coming in. So I'm building that JSON while waiting for the next person. So this is very powerful. I can stream, and when I'm tired and I'm just stopping the stream, the JSON will be closed, and I don't need to wait for the entire stream to be finished. The other way around, it's the same thing. If, for example, a JSON is coming in, and it's a very big JSON file that's being streamed to me, I can deserialize while it's coming in. And when I have the first 10 people, for example, but millions are coming in, after the first 10, I can say, okay, stop the stream, and I have deserialized only the first 10, and I don't need to wait for the rest of the data to come in. So it's more performant because I can specify specifically which part of that data I want to serialize or deserialize. So very cool. And then finally, there's also some new performance added. So I talked about source generation before. So basically, when we are serializing and deserializing JSON into models and vice versa, we are using reflection. We are using reflection to see, okay, in JSON we have this property. Does our object have the property with the same name or with an attribute that tells us that that's the property name? If that's the case, I can just copy those values. So we need a little reflection to do that, and that takes a little bit of time. If you do like serialization and deserialization of millions of objects, it's going to cost you because that will take a little bit longer. Today, we can have source generation for that. So source generation means that our compiler will generate source that we don't have to write. Why? Because when we serialize or deserialize data, we know what the data looks like, and we know what the object looks like. So we can just generate source code that already does this for us without the need for reflection. And how you can do that is by using the JSON serializer, and you can specify an additional property that uses a context. You need to generate a class, a context class that knows about your objects. And you just add that class like this. This is a partial class data point context, which is a JSON serializer context. And then you can add attributes for all of the objects that you want to add support for source generation. So I have created an object that is a data point, which is this one. It has ID, title, description, and then it has like a left and a right node. It's basically nodes in a tree. And I want to add the data point itself, but also an array of data points. And this class is empty, but it is partial, which means if I compile this, source will be generated and added to this class. And that source will work. It will serialize and deserialize my data without the need for reflection. And sometimes it works, sometimes it doesn't. But if I run this, sometimes it's slower, sometimes it's faster. And that's because it's just one example. If you run like millions of serializations, it will be quicker. So let's just get our, oh, that's nice. Yeah, it's beautiful. Okay, let's skip that. Yeah, I know when I have some time remaining, I will try again. I need to shut down Visual Studio, start it again, and then it will work. Anyone knows that? When something doesn't work, in the past it was the same thing for my students. I don't understand this exception, and I would tell them, I also don't understand the exception. Close Visual Studio, start it again, and it will be gone. And most of the time that's the case. Yeah, and then I'm going to end with some new link features, which is number 6. I have some more examples, but as I told you, I like to talk for 4 to 5 hours, but I only have one. So I'll stop with this. So we have some new link features. So first of all, a couple of C# versions ago and .NET, we have some new classes. We have index classes and range classes, which means when we use indexes, we cannot only use an integer, but we can also use an index or a range. Why? Because basically today we have something like this. I can get the element at, I don't know what's that called in English. In Dutch we call that een hoedje. But this is 2 from the end, which means not 2 from the beginning, but 2 from the end, which can be if you have many objects and you want the last one. Today it's like calculating what's the length and then -1. So now you can just get the last one from the end, which is the first one from the end. But we also have ranges like this. These are, maybe this is more clear if you didn't know about this. This is from the 2nd element up until the 6th element. So that's like a slice within your array. If you do something like this, it's from the beginning up until the fifth element. The fifth element, good movie. Or from fifth element up until the end. Of course, those are still indexes, so 5 is not the fifth element, but the sixth element, so be careful with that. But now LINQ understands these features, and this is new from .NET 6. Before, LINQ did not understand these new things. So you can do like take, and you don't need to do skip, because you can do take from 5 up until the end. Beforehand, you needed to do the skip and the take together. You can have all sorts of variants on this. Skip the last 2, or you can take from the beginning up until 2 from the end, which is the same thing. So here's basically a choice for you as a developer. What do you like most? If you think this is more clear, just use this. If you think this is very cool and it's more clear to you, you can use that. Both do the same thing. Very cool. Why the hell did we need to wait so long for this feature? Single or default, first or default, last or default. The or default can now be specified by default. Previously, the default was always the default for that specific type. Like a string is a reference type, so the default string is null. For an integer, the default is 0. For a boolean, the default is false. Today, finally, you can specify the default value. If you think an integer has a default of -1, specify this, and this will be returned to you if this cannot be found. So very cool feature. We can do chunk, which is also a new method. We can chunk a list into multiple lists. What do we have here? Oh my God, minimum by, finally. So if you have an object and you cannot order those objects, but you want to order them by a property, now you can do min by. So we have a list of people. I want the people that is minimum by its age. So I can get the person with the lowest age. Finally. What the hell was this again? Try get non-enumerate. Yes. So when you have a list, or not, when you have an IEnumerable, you know that an IEnumerable can be enumerated beforehand, yes or no. Maybe you've enumerated it before, or you didn't. With the try get non-enumerated count, that's a method that says I want to have the count of this, but only if it's not enumerated before, so that you're not enumerating it a second time. Now you can just ask that question. It's a Boolean, true or false. And when it's true, you can do something. And when it's false, you can do something else. So this can be nice if you don't want to enumerate an IEnumerable multiple times. Yeah, and that's nothing to add. So with that, there's about 7 minutes remaining. So I'm just going to shut up. I had some async dependency injection, which is very simple. Just look at my example. You can now do async disposable, blah, blah, blah. You can dispose of services that in your dependency injection by doing await create async scope. I had some examples for source generators, and I had some examples for hardware intrinsics. And with that, I'm at the end. If you want to look at my GitHub repository, you can use that link in the bottom, or you can scan the QR code. And if there's any question, I would love to hear them. Silence.
Thank you very much for the session. And now we have a few minutes for the questions. So if you have any question, just raise your hand and my colleague will come to you. I will start with a question from the online discussion. So you can raise your hand at any point and we'll follow up with that. So the first question is, can you give us some examples of when to use records? Is it a good feature to use for data transfer objects or for modules for the web API?
Very good question. So indeed, why would you want to use records? Well, today when I'm using data transfer objects, for example, I'm always using records. And it's another reason because it's like more performant, because it really isn't, because it's a class. So for the .NET runtime, it doesn't really matter. But I like the fact that when I'm doing DTOs, I can create simple DTOs in just one line of code. I can do like public record person and then have the constructor in one single line. And if I have a project that contains 20 DTOs, I can even just create one single file with the 20 DTOs as 20 lines of code. So in just looking once at one single file, I know these are all my DTOs, which I think is a cool feature. But something that I didn't show you, and I'm very quickly going to show you. is that the powerful thing of records is that you can easily copy them into new objects because they are immutable. When you want to create a copy of it, it's very easy. It's just one line of C# code. So here, and so if I have one person, which is myself with my age, and I want to create a younger version of myself, I can do var person3 equals person2, which is me, with the age of 25. And this will copy the previous object and it will change that age into 25. So if you're doing stuff like this in your code base, so if you're not changing the state of objects, but you're just generating new objects with a slightly different state, it's very easy to do it like this. With a class, which is a reference type, you cannot do that. So I hope that was an answer to that question.
Maybe just a little follow-up. Is this a shallow copy or a deep copy?
It's a deep copy. So if records can use other records and they all have these features automatically added to them, so it will deep copy your object automatically.
Any question from the audience? Nothing so far, so let's follow up with the online questions.
All right.
Is there any functionality to control how time-only and date-only gets serialized into JSON? Like for datetime, we have time zones and date formats and this kind of stuff.
Very good question. I cannot answer that. I'm sorry. I have to play around with it. I have to try it out, but I don't know by heart.
Okay. And the next one goes into intrinsics. So could you elaborate on intrinsics? A few examples would be super cool if you have something like that. And the person is asking that looking forward to using some single instruction, multiple data instructions.
Yeah. So yeah, the reason why you would use that, so single instruction, multiple data already tells you what's going on. Basically, your CPU has a functionality that when it adds two numbers together, it will always add a whole vector to another vector. So when you add two numbers together, your processor puts your first number in the first vector and your second number in the second vector, and all of the other values in that vector are basically rubbish data. And your processor will add those two vectors together, and it will just return to you the result of those first two numbers. So you're not using the full potential of your CPU. So if you know you are adding lots of data together, so multiple numbers together, and with multiple I mean thousands of numbers together, you can actually use those methods like this. So this is an example that I did. So I'm basically calculating a sum of 250 million numbers. So I generate 250 million numbers, and I'm adding them all together. So you can do that using a for each and just adding all the numbers together very quickly, or you can use that single instruction multiple data. And for that, you need to create a vector with a specified length that depends on your processor architecture, how long a vector can be. You just put all of those numbers in vectors, and then you're just adding vectors together. So I have a result vector, and I'm adding a vector with a slice from my source data to that. And in your processor, it's just one processor tick, and it will add that data in parallel automatically for you. So it's obviously a lot quicker to do that. And libraries that already use this today are, for example, machinelearning.net, so ML.net, because for machine learning, there's lots of calculations needed. They are using this functionality, and because of that, that library has become much, much more performant. If I run this example, if Visual Studio works with me, it does, it will calculate the sum, and it will do it using just a for each, which is, let's take the last one, which is about 900 milliseconds. It will use simd, so it's adding the vectors together, which is about half the time, so 500 milliseconds. And then you can even go further and directly call into your CPU functions, and this only takes 300 milliseconds. So I'm going from 900 to 300, so that's times 3 in performance. Of course, that final one is a little bit more tricky because you really need to ask. The support is there in the base class library, but you really need to ask, does my CPU support SSE2? If you're using ARM processors, like in a Raspberry Pi or your phone, in that case, it's like ADV simd. If that is supported, then you need to do stuff like this. SSE3, horizontal add, and you can see in that pop-up that is really the name of the function in your CPU, underscore M128I underscore MM and so on. So a horizontal add, and that's really directly calling that function of your CPU. So it's very powerful, but of course you need to add some code to make that work. So again, hope that's an answer to that question.
Thank you very much. I believe we have one question from the audience, and that will be the last one. So.
All right. Do we have a question?
Do we have? Oh.
Yes.
Please wait.
Yeah, I have a question regarding the source generation. So as far as I understand, is kind of analog of what we have, for example, for XML serialization, when we had this SGAN tool, which was kind of generating precompiled classes for serialization. So is it kind of correct assumption? Or how this sort of generation can be used?
Yeah, I'm not sure if I understand your question correctly, but you're talking about XML serialization, and you're already generating source based on another way of doing that, or?
Yeah. So for XML serializer, I think there is SGAN tool, which goes with it, and you can kind of on the build time, you can specify that precompile those, so it will precompile those classes for serialization, and it won't use the reflection.
Okay, yeah, indeed that's an alternative. The power of source generation actually comes from. I did a small example. Sometimes it works, sometimes it doesn't. I'm not sure why, but I did an example here, which is a very stupid example, but I hope it explains it. I'm creating an HTTP client for some service. And if you use Swashbuckle, which is using OpenAPI or Swagger, it generates like a JSON file that describes what that server looks like, what the endpoints are, what the models or the DTOs are. And what I did here as an example is create an HTTP client class, which is empty. There's nothing inside. And source generation means that if I compile my code, that this class will be filled up automatically with all of the client methods that call the endpoints. And the cool thing about that is you as a developer do not see that. It's not physically here. But if I go to my program class, I can call .getWeatherForecast, which is a method that does not exist on the client. And you can see that Visual Studio is telling me. So this is a bug on my end or on the end of Visual Studio. I'm not going to blame anyone here. But in source generation, this normally should work, because when you're typing inside of your editor, your code is compiled in the background automatically. And it also generates the source at that point in time. So you have IntelliSense of source-generated code that is not there, but it is there in the background. So it's generated for you while you are writing code, which I think is a very powerful feature. And that's basically the cool thing on source generation. You can use like T4 templates to do the same thing for source generation, but of course then it's generated after you really compile your application and not while you are developing in Visual Studio, for example. So I hope that's an answer to your question.
Yeah.
All right, perfect.